let's assume that this is GPIO A and we want to write to pin 2. Go back to the reference manual and search for the memory map again. We know that the GPIOs are connected to the IO port. So scroll down. On this side we have the bus. So we will look for the IO port, and this IO port starting from the base address, that is GPIO A, and they are laid down consecutively for GPIO A to B to C to D, and they are 1 kilobytes apart. We are going to start with GPIO A, but before that, just create a directory wherever you want it and create a file. I called it main.c, so you can include this. We want to set GPIO A, let's say pin 3 as output. This is what we want to do, and also after that we want to set GPIO B pin 5 as analog. Alright, we are going to do this. Go back to the reference manual and we will copy the base address of GPIO A. Now before you paste it, whenever we are addressing memory, we use the volatile keyword, and as we said, we are working on 32-bit architecture. We cast the address to 32, and inside here we just paste it, and we need to add something to it. Before that, make sure you close the gap here. As we explained earlier from our diagram, a peripheral contains a couple of registers. Go back to the reference manual and search for GPIO registers. These are GPIO registers. We have a couple of them. Click on the first one. Now we want to set pin 3 GPIO A as output. According to this, to set a pin as output, you need to set the first bit to 1 and the next bit to 0. Okay, we are dealing with pin 5. Pin 5 means that is 16 pins. Set mode 5 as output, so you set bit 10 to 1 and bit 11 to 0. Before we set that, just look on top here. Registers are arranged inside peripherals, one after the other. If this is our first register, it means that it has an offset of 0. It's the first register inside the peripheral. Okay, so it has the same address as the peripheral. Now the next register is the GPIO OTYPER. Because this is 32 bits, that is 4 bytes. Okay, so the second register will start at this offset and it just goes on. The third will be 0x08 and the next one will be 0x0C, just increasing by 4 bytes. I want you to remember that. Go back to the VS Code, and here we add the offset. Because we are dealing with mode R register and it is the first register, the offset is just 0. Alright, so we do this as the offset. And now to set specific bit inside the register, first you have to make sure that it is cleared, right? So to do that, we have to end it with the number of bits we want to deal with. Each mode deals with 2 bits. So if we want to set 2 bits in here, then we have to look for a number that has, let's say, 2 ones in there that we can manipulate, and that number is 3, right? If each mode had 3 bits here, then when we come here, we actually look for a number that has, let's say, 3 consecutive ones, and that will be 7. All right, but now we only need a number that has 2 consecutive ones, and we can use 3 to do that. So we take our 3 and we are interested in pin 3. Okay, now pin 3 starts at bit 6 and bit 7. So come here and we are dealing with pin 3. 3 times 2 is 6. Okay, so we are going to shift 6 to the left. All right, so when we do this, and that is it, we have cleared a bit, clear bit 6 and 7. Now after clearing it, then we will set it to the particular mode that we want. I'll copy and paste it here. Instead of end, we will have to do all here, and we remove this. And because we only need to set bit 6 to 1, we can't use 3, right? Because if we use 3 here, it will set both bit 6 and 7 to 1, but we don't want that. We can use 1 like that, and this is going to set it. So by doing this, we have set pin 3 of GPIO-A as output, right? Now the next one, we want to set pin 5 of GPIO-B as analog. So the first thing we want to do is to go to the reference manual, get the address of GPIO-B. Let's do that. So we come here, we search for the memory map. We will go to the IO port. This IO port, GPIO-B, and the starting address is here. So just copy this, go to your VS Code, and we will do the same. We are pointing to address, right? So we have to cast it to volatile, and we are dealing with 32-bit. So we cast whatever address to UART32, paste the address that we copied, and now once we have this, we will go to GPIO-B and get the registers. But don't forget that GPIO-A, B, C, they are just instances of the same peripheral. Okay, go back again to the GPIO registers. You get the mode R register right here. Yeah, so it's 1 okay. Pin 5 corresponds to mode 5, and with mode 5, 5 times 2 will give us 10. So we start from bit 10 and bit 11. We will set bit 10 to 1 and bit 11 to 1. Now mode R register is at an offset of 0x00. It's the same for different instances of the same peripheral. Okay, so the offset will be 0x00 here. Make sure you remove the space. First, you need to clear bit 10 and bit 11. Okay, we need 2 bits to do that, and 3 will help us. So we use 3. We move it to bit 10, clear bit 10 and 11. After clearing it, now we will set both bit 10 and 11 to 1. So I'll copy and paste this, and we will use all. This time, because we need both bit 10 and 11 as 1, we are going to maintain 3. All right. If we wanted to set GPIO-B pin 5 to output, we use 1 here. All right, we just use 1 over here. Yeah, that is it. Very simple. You get the address of the peripheral, you get the offset of the register you are dealing with, then you go ahead and you set your bit. All right, now go back to the GPIO registers. What if we want to write something to a GPIO? Okay, let's say we want to write high or low to a particular pin of the GPIO. What are we going to do? Let's try that. Let's look for the data output register. This is the data output register. It means that whatever we write here will be written to the pin. If we write 0 here, then it means low, right? If you write any number here, it will be interpreted as high. So we just write 1 and it will be interpreted as high. So what if we want to write high to pin 9 of GPIO-C? Okay, let's write it here. Let's see. I think you guys can take a few minutes and work it out, but we will do it just as we did for the others. Okay, we'll go to our reference manual, go and get the address of GPIO-C. But if you watch closely, we said that the GPIO peripherals, that is A, B, C, they are at an offset of what? 400. So A is 000 and B is 0400. Okay? So you can see that C is going to be 0800. That is very easy, but not to confuse you, go back here and let us search for the memory map. Okay, once we have the memory map, we go to the IO port bus, and this is GPIO-C, right? So go ahead and copy this. You write the same thing, nothing different, volatile. You cast it to UART32 inside here plus offset, right? So we write it here plus the offset of the register we want to deal with. This time we are going to write to the output data register. Okay, so we'll go back and get the offset of the output data register. Search for GPIO registers. Okay, so the registers are here. The output data register is this. We can see that the offset of the output data register is 0x400. all right, so you can copy that. When you come here, you add that. So write 0x14, and we just want to write high to this register, but not only this register, to a specific pin, that is pin 9, right? So we need to go back here. This is pin 9, and pin 9 is exactly at bit 9. Okay, so bit 0, with 1 up to pin 9. So we are going to write high to pin 9. So go here, and this time we can just use all, right? And because we are writing high to pin 9, we can just shift this, right? And once we do this, basically we shift it to the left 9. So if we compile this program and we flash it to our STM32 board, whatever is connected to pin 9 is going to receive voltage. So if we have LED, then LED is going to set high. But I'm just curious, why don't you try write low to GPIO pin 9? What do you think is going to be? We want to write low to GPIO pin 9. Don't forget, GPIO pin 9 is already high. So if you want to write low to it, what do you think? Are you going to do this? If you do this, obviously 1 is shifted to the left 9 and we invert it, so we get 0. But since pin 9 is already 1, if you do 1 or 0, it will still be 1, okay? So to do that, you have to use AND. So when we end 1 with 0, then we are going to get 0. Let's move on.